Thank you very much for joining Microcom's webinar with EBand Communications. My name is Jeff Beasley. I'm the Director of Training. We have Joey England on the line from EBand. He'll be going over some stuff, in which case, if you guys have questions, you can go ahead and put them in the question box, and we're going to go through the slides, and then we'll have question and answers afterwards. So if you guys have any questions, just go ahead and send them in when you get them, and we'll go through those at the end of the presentation. With that, let me give you control of this. And you should have control of the slides, Joey.
All right. Well, good morning, everybody. As mentioned, my name is Joey England. I'm the North American Sales Director for EBand Communications. We're based out of San Diego, California, and trying to figure out how to, oh, there we go. A little bit about, too far. Bear with me. Trying to learn to control here. A little bit about EBand Communications. We were founded in 2006. We're a leading supplier of high-capacity gigabit Ethernet in the 70 and 80 gig frequency bands. First few years of our business, we put a lot of focus on the telecommunications customers to deliver a 5.9 type service to telecommunication-based customers, Clearwire, T-Mobile, AT&T, those types of folks. Currently, to date, we've got over 8,000 terminals deployed in 25 countries. EBand's RF technology is the monolithic millimeter wave integrated circuit. It's partnered with Northrop Grumman, and it actually gives us better transmit values and receive values. We are currently releasing a 64 QAM modem-based radio. We call it the Eagle. That and the Mini, which is actually being announced this week in the show in Barcelona. And we're also, as mentioned, we're launching the small profile micro and pico cells for point-to-point systems. So just a little bit about EBand. The technology is moving the mainstream carriers, and we're getting more and more focused. We're still staying focused with the carriers, but we're trying to get into the enterprise world as well. And we felt that if we could successfully cater to the carriers, that the enterprise side should make things a lot easier. As mentioned, we're with the world's top 30 carriers so far. The frequencies are open commercially worldwide. The main applications today are macro backhaul sales, and we're also doing pico sales. Looking into the future, potential millimeter backhaul. The beauty with the 70 and the 80 gig is we're uncluttered. The 80 gig frequency is that of most microwaves. I mean, we have so much spectrum to operate in that the clutter is very minimal. It requires a light license, which with the FCC it's just a fee, and from there the customers are allowed to transmit and receive from there. As the technology keeps maturing, the cost of the equipment and the form factor just keeps going down. One of our largest customers was Clearwire. With their 4G networks, we were in all the major cities with those folks. Chicago, Philly, San Francisco, Vegas, LA. We've deployed thousands of radios with those folks, which kind of got our foot in the door with the carrier side of things. This is a great photo from Chicago shooting out of the what used to be. It's called the Sears Tower now, but on the 88th floor, there's 12 links shooting out of this one building all throughout the metro area of Chicago. Also with Sprint, we're based, out of their Overland Park in Kansas, and we've deployed all over with Sprint as well. Great customer that just gives us a lot of exposure as well. Some of the top benefits of EBand is the 70 and 80. It's just cheaper, and the total cost of ownership is cheaper than the 18 to 38 gig microwave. Plus, you get the 4 times performance. The licenses are readily available. License fee with the FCC. If what we'll do, or you folks can do, is register, and then your customers will be charged a one-time fee to license these products. The license is good for 10 years, and it's just a matter of filling out the lats, longs, and the information, submitting the payment, and customer can transmit from there. There's no frequency coordination with as traditional microwave. The way the license operates is it's a first come, first served basis. Once that the license is applied for and paid for and built, first one there gets that spectrum. The product is a full duplex GigE over a single radio versus traditional microwave of 400 or 800 megabits. As mentioned, this is full duplex GigE, a gig up, a gig down. We also, with the Q product, we don't throttle down. A lot of microwaves will throttle down using QPSK. In the event of a rain fade or something to that nature, they'll go from 800 megabits to 400 megabits down to 50 to try to keep the link alive. With our MMIC chipset, this allows us to get greater distances without actually having to throttle down. So, as the slide says, 2 to 3 miles and still maintain a 5/9 solution beats out microwave rather easily. The equipment can be built in a ring architecture, a star architecture, point-to-point, point-to-multi-point, and last but not least, as mentioned, the total cost of ownership versus 18 and 38 gigahertz microwave. You get 4 times the performance for around the same cost. Sorry, I jumped too many slides. There we go. All of our radios are currently manufactured in the USA, right down in San Diego, California. Everything's engineered there, and we have a facility about 3 miles from our corporate office where everything is built. We have a great cooperation between the manufacturing and the R&D folks, so as changes are needed, things can be implemented relatively quick. Everything happens in a real-time type environment. Some of the folks that we're finding that needs GigE bandwidth is a lot of enterprise interconnect. Since I've taken over the North American sales, I'm finding all kinds of applications from local government, sheriff's offices, hospitals, schools. I'm quite surprised at the demand that's out there. Starting to get more and more exposed to the enterprise side, and quite surprised, as mentioned, who all can use this technology. One of the big applications lately has been the financial district. New York City and Chicago folks are finding that the low latency products is something that is highly desired, with them moving all of the trading centers 30 miles outside of the cities. Something to do with the, keeping the country safe. With our product, we have a super low latency, and we're building even for the financial sectors. It's quite amazing. The 3G and 4G backhaul telecom carriers, we've always been involved with them, but like I said, we're spending a lot more time on the enterprise side and realizing that there's quite a market there. Last but not least is government, Department of Defense. Those folks, the DARPA projects are also involved with millimeter wave technology. So we're moving forward in quite a few different aspects. One of the great applications is last mile access. Fiber optics is readily available, but when you start getting into metro areas, as we all know, to trench and put in fiber, you're looking at anywhere from $200 to $400 a foot to dig and trench. This is a great solution for reaching these last miles. They already have a network there, but they need to get bandwidth to another building. This is a great solution for that, and considerably cheaper than trying to trench, especially in the metro areas. We're finding that about 1/10 of the cost of fiber, and this thing can be deployed in hours. I mean, once the link's registered, which is a matter of just getting on the website, registering it, there are other costs involved, with zoning and permitting, but once those things are out of the way, these things can be deployed literally in hours. A little bit about the product roadmap. Currently, the products out there is the E-Link LR and Q. The Q is the main product that we have, and I'll discuss the specifications of those in a little bit. As mentioned, the Eagle and the Mini the Eagle was released late last year. We've got trials going on right now for the Eagle, and last but not least, the Mini, which is the small form factor, and you can see in the photo there. That's designed for small small picocells, basically light pole to light pole, where some of these customers are trying to, put in a 4G network. As mentioned, the Mini was released in Barcelona this week, so we're pretty proud of that, and I'll be getting some specs out for that here pretty quick. A little bit about the Q, and the reason I chose the Q is this is one of the best products for our enterprise customers. It comes in different versions. It's a GigE or CPRI. The CPRI is more for a backhaul carrier, and the GigE is the standard, what we would mostly use on the enterprise side, and then the ULL, the ultra low latency. Some customers require, excuse me, ultra low latency. Our Q product has has just less than 500 nanoseconds of latency, and that's from radio to radio. Of course, once you add switches on each side of that, things change. The latency drastically increases, but for these high-frequency traders out there, the ultra-low latency is a very important factor. It's a GigE full duplex layer 1 device. Now, the beauty of layer 1 is you can pretty much throw anything into this radio and it'll transport it. We don't really care about the bits, the streams. All we're doing is converting it to RF, transporting it across. So you can look at this gear almost as invisible fiber. It's layer 1. We don't care. You start working with layer 2, and where the packets and the switches have to have timing and everything else. Layer 1's kind of fun. You just plug it in and go. The standard Q product has also low latency, less than 5 microseconds, and then the ULL, they're saying 400 nanoseconds. So latency is a big factor for some folks, so we try to emphasize that. This is a low power consumption. It runs on minus 48 volts DC and draws 38 watts. We have a PoE configuration that plugs into a standard 110 outlet. The power consumption is less than an amp. As mentioned, layer 1, it's transparent and SYNC-E and complies to the IEEE 1588 version 2. We have the unit has a field changeable GigE interface, so the GBIC in the radio can be accessed. Our older products, we used to specify what kind of interface you would want, and then we would actually, it was within the radio, so we would be required to pull the cover, change out the GBIC. In today's Q, your customer decides they buy a multi-mode radio and want to change it to a single mode. It's just a matter of changing a GBIC on the side of the radio. It's field upgradable, and totally easy to do. As mentioned earlier, it will operate over power over Ethernet, and it also has a redundant power. A lot of customers like to run 2 power supplies up to their radios in the event of a commercial fail, where they'll have one power connect to a UPS and the other to a standard 120 volts. RF channel tuning. This radio has currently 5 different channels to choose from. In the event that there was another link, they could actually choose different channels so we can get away. One of the things that these slides don't mention is the interface. Very, very simple interface. To get these things up and running, it's a matter of the customer logging in, turning the transmit power on, and start aligning. The simplicity of the user interface is great. These are also field upgradable to a 2 gig system, and in order to do that, we would add a coupler and then a second radio, and then using horizontal and vertical polarity, we would be able to get up to 2 gigs. And then last but not least, we want to talk about extended temperature. These radios operate in Mongolia as well as Yuma, Arizona, and Saudi Arabia. We've hit the extreme temperatures. Looking for the spec right there, the minus 49 degrees Fahrenheit clear up to 140 degrees Fahrenheit is what we cover. We've actually had some in Yuma where I've taken readings from the radio, and they're operating at 165. Yet the ambient temperature is not that, but the internal radio temperatures, reach well above 150. It's quite amazing. Once again, the photo is a shot in Chicago where we've shot 15 EBand links coming off the 88th floor of the Sears Tower, now called the Willis Towers. You know, kind of give you an idea of how many radios you can put up to. We've got one mast in that building there where we've got 5 radios, and all we require is a 3-degree separation. So some of the advantages of this E-band is we can put multiple radios on one mast, and we're cutting down the civil cost, you know, the construction cost of actually deploying these things when there's customers that need multiple multi-point systems and things of that nature. With that, I've been through the slide deck, and I'm about 3 minutes ahead of schedule, and at this point we'll turn it over to Jeff and then open it up for any questions.
Okay, Joey, thank you for that. I got a couple of them here. One of them, I think you might have covered part of this, was on the licensing fees. How much is the licensing fee, and about how long does it take to go through it?
The licensing fee, EBand actually charges $500 with the FCC, and I want to say it's CommScope. You actually set up an account, and it's a one-time fee of $500, which, you know, you folks as the distributor, I would recommend that. And then if EBand registers, we charge $500, but the actual cost is $75. Once that's set up, it takes about 3 days to set that up. Once that's set up, and you have a customer that needs a license, it's a matter of just filling out the paperwork, which takes about 10 minutes, ask for lats, longs, elevations, paying the fee with a credit card, the $75, hit submit, and from that point you're allowed to transmit. Okay.
And then another one here was in point-to-multipoint mode you talked about. What does your throughput drop off to?
Okay, when I say point-to-multipoint,
were you talking
no drop off
points?
What I'm saying is on one mast you can have multiple points coming off. Each link would still be a 1 gig.
Oh, okay, so it's just multiple point-to-point links on the same mast.
Right. Where I was going with that is you can put multiple radios on one mast, where traditional microwave you need a larger separation.
Correct. Okay. Let's see. Next one here was on the Mini at 1 gigabit. What's the distance you're looking at for that?
The Mini right now, to maintain a 4.9, is right around 1.5 miles. We don't anticipate anybody running it that far. The reason being it was designed more for light poles, you know, into metro areas, take, you know, Los Angeles or Boston, shooting from a light pole maybe to a top of a building, back down again, and dropping bandwidth off as needed.
Okay. And then another one here on the Q, is there a fiber interface only or just Ethernet? I know you covered about the power, that there's two power supplies.
The Q we talked about a little bit is we have multiple interfaces. We can do a copper, which would be a Cat5e, or Cat5 or Cat6e. We can do multi-mode or single mode. The beauty of the Q is that that actual interface is field upgradable, or you can change it at will. It's just a GBIC that plugs into the side of the radio.
Okay. And then when you talked about how they come set up, are those already you just have to literally log on and, you know, turn the power on them. Are they already pre-paired to the other side? Are they an A and B unit, or?
Each radio comes set default to the E channel. Depending on how it was licensed, they may have to change that to the A channel or the desired channel. Most of the time, what's neat about the E-band is there's not a lot of clutter out there. They do come set default to E, and most people license them for the E. You know, if they're putting in multiple links, you know, like on the last slide, they're shooting down to that UBS building. If they wanted to put in 3 links, then they would, you know, the second and third link, they would want to change the channels a bit. And we could also do an offset, you know, through polarization and things to that nature.
Right, but there, as far as the radios themselves, is one considered like a primary, and the other one is a secondary node, meaning they're already they're already preset to talk to each other, or
they're already preset. You've got a low band and a high band. It's a, you know, it's a matter of turning the transmitter up and aligning. They're preset already. They're ready to talk to each other. Just find the other side.
Perfect. Okay.
Perhaps I could talk a little bit about the interface to it. You know, a little bit, you'll have to set a laptop up or a terminal. You know, it uses IP, so it's a web-based type GUI. You know, make sure that you're in the same subnet, and it's just a matter of typing an IP address into your address bar of your web browser.
But they come with different IP addresses.
Default, we have 2 IP addresses. We have
Perfect.
a high band and a low band, and the low band, 10.100.7.247, and the high band's 248.
Okay.
From there, the customer can change the IP to whatever they desire in the subnet, but for default purposes, we carry 2 IP addresses.
Okay. That was all the questions that I got in. Anyone have any else? Okay, well, with that, I'll start wrapping this one up as an easy one. Thank you, Joey. There's a lot of good information on this one. I know 70 and 80 gig license links are not something that we deal with too much of, but it's something that definitely is an open spectrum, especially with as crowded as all the license-free stuff is getting now. So thank you for your time. If anyone has any questions, you can contact your Microcom sales rep. You can also contact sales@microcomtech.com. If you need a copy of this slideshow, also we've recorded this, so it will be on our YouTube page. So just go ahead and search for Microcom and EBand on YouTube, and you can pull this whole presentation up. If anyone has any questions, last chance. Okay, Joey, thank you very much for your time.
Thank you, everyone.